Hello, Calculus, and welcome to 4.2. This is derivatives. We're going to do the product and the quotient rule today. Now, the product rule, I wrote it out the first way that they do in the book. I don't do it that way because I always do it backwards of the way they do it, which is the same thing, which you'll see in a little bit. So let's try not to get confused and follow along. I think you're going to like these two rules. They're kind of fun to do, not too bad, and we're not doing a whole lot else with them. So let's go. So we're going to calculate the derivative of the products, quotients, and then we're going to find marginal average cost. All right, the first rule is the product rule. This is the one that I usually do backwards of the book. All right, when they do this, this means I'm going to find the derivative of two functions multiplied by each other. To do so, you take, all right, when I do it absolutely backwards. I do the derivative of the first times the second plus the derivative of the second times the first. Your book writes it, the first times the derivative of the second plus the second times the derivative of the first. It's irrelevant because addition is commutative and I can do them in any order. All right, the next thing I just kind of wanted to show you. This is called the paragraph proof. You will not have to do one, so don't panic, but at some point in calculus, like when you get into Calc 2 and 3, you may, because paragraph proofs are the way that a lot of things are written. And I just wanted to introduce them to you. This is an informal paragraph proof. I have not done a formal paragraph proof. Here would be at least a page long, all right? But an informal, just to kind of get you used to the way of the wording. Okay, we have shown that the derivative of the function is the change of the function as the change approaches zero. We've already done that. Now, consider the above diagram. So we're looking up here. The area of the large rectangle, which is here and here, is u of x plus h times v of x plus h. So the first function times the second function. As h approaches zero, all right, so as this part disappears, so as this part and this part go away, right, the green section disappears, leaving u of x times v of x. So the smaller times the smaller, or the white rectangle. Okay, in the function v plus v of x, okay, times the change in the function u. So as u is changing, so as h is approaching to zero, which shows us that this here becomes this little triangle. All right, I know that's confusing. I got it. I just wanted you to understand that you could be asked to write this out in words. Okay, so as h approaches zero, green section disappears, leaving you u of x times v of x times the change in the function u, which is really kind of cool. All right, I know you don't really care, but just an introduction. All right, so let's get back to finding our derivatives. I have two functions here, x plus 3, x squared minus 8, x squared minus 5x. So to find the derivative, we take this one times the derivative of v of x plus this guy times the derivative of u of x. Are you ready? So the first, square root of x plus 3, times the derivative of x squared minus 5x, which is 2x minus 5, plus the second, x squared minus 5, so you leave this one alone, times the derivative of the first. So this is x to the 1/2 power plus 3, so the derivative is 1/2 x to the negative 1/2 power. Good to that point? Now all we do is the math. So we have to do all that distribution. So I changed this here to a fractional exponent, so everything was matching. And then we just do the math. So x times 2x, which is 1/2 plus 1, which is 3/2, minus 5x to the 1/2, plus 6x, minus 15. Now we do the second part. So we take this guy times this, which is 1/2 x to the 3/2 power, and then negative 5x times 1/2 x. Now x and x gives us to the 1/2 power. Combining like terms, so we have 2x to the 3/2, 1/2 x to the 3/2. So we have 2.5 or 5 halves x to the 3 halves. Now we go to the x, the next power, 6x. Now the 1/2, so it's minus 5. Minus 5 halves, it's negative 15 halves. And last number. Nothing too major. Okay, pause and try yours. Okay, your first step is you should have recognized your first term. Your first function is x cubed plus 7. Your second function is 4 minus x squared. All right. So now when you do your derivative, so we're going to write this, the derivative of y with respect to x, just or something a little different. You take the, I should probably do it the way they did. Okay, you're going to take the first, which is x cubed plus 7, times the derivative of the second. So the derivative, so let's write these down. The derivative of v is minus 2x. The derivative of u is 3x squared. So we take the first times the derivative of the second plus the second times the derivative of the first. And then you have to do all of that math. So now we're going to go through and we're going to distribute this out. And we've got negative 2x to the 4th minus 14x. Distribute this one out and we have plus 12x squared minus 3x to the 4th. Combine our like terms and we get minus 5x to the 4th plus 12x squared minus 14x. And that is your derivative of this one using the product rule. I hope you did well. Okay, let's continue on here. All right, this is the quotient rule. I think this is why you see why I usually do the other one backwards. So you have two functions divided by each other. So you take the derivative of the first times the denominator minus the derivative of the denominator times the first all over denominator squared is how I usually read that. So here we go. We got 5x plus 7, 4x minus 2. So let's just write these out so everybody understands where we're at. So we're going to say u is equal to 5x plus 7. So then u prime, or the derivative, is 5. We know v, or the denominator, is equal to 4x minus 2. So then its derivative is just 4. So we take the derivative of the numerator, which is 5, times the denominator, 4x minus 2, minus the derivative of the denominator, which is 4, times the numerator, all over denominator squared. Now just do your math. So you get 20x minus 10 minus 20x minus 28. Combine your like terms, so those disappear. Negative 38 over 4x minus 2 quantity squared. All right, pause and try yours. So you know u is equal to 3x plus 2. So u prime is equal to 3. You know v, your denominator, is 5 minus 2x. By the way, this step right here is definitely not required. I think you could probably do that in your head without messing up. So now we want to do the derivative of y with respect to x. So we take the derivative of the numerator, which is 3, times the denominator, 5 minus 2x, minus, now you're taking the derivative of the denominator, which is negative 2, times the numerator, 3x plus 2, all divided by the denominator squared. Okay, now when you did your work, you should have done your distribution, and you would have gotten 15 minus 6x plus 6x plus 4. All right, your 6 is x. Oops, oh, I'm sorry, I forgot the denominator. All over 5 minus 2x squared. X's cancel, giving you 19 over 5 minus 2x quantity squared. And you were done. I hope you did well. Okay, next one. We're going to put it all together. You actually have two options here. You can do it this way, which actually is harder but these functions up here are very simple. So if they're simple, the second method is easier. But if they are not simple, this is the easier method. So you need to know both. So I'm showing you both so you can choose which one to use when. All right, so we're dividing. So what we do is you take the derivative of the numerator, right, times the denominator, minus the derivative of the denominator times the numerator, all over denominator squared. Well, we know the derivative of 2x plus 7 is 2. We know the derivative of 3x minus 4 is 3. We know the derivative of 5x plus 2 is 5. So we're going to use this. So now that we've done this, I have to take the derivative of this guy, which means now I'm using my product rule. So it's 2 times 3x minus 4, derivative times second, plus derivative 3 times first, right? But don't forget your 5x plus 2, minus this in here is just the straight 5 times 2x plus 7 over 3x minus 4, all over denominator squared. We're not going to touch him. Now it's all math. So you distribute your 2, you distribute your 3, you combine your like terms here, then you distribute again, right? Over here, you're distributing your negative 5 through, you distribute it over here. So it's all this distribution. Combine your like terms up here, and your final answer is this. Nothing too major. A lot of work, yes. Careful of your signs, agreed. Option 2 is you can actually take this numerator, since it is a very easy distribution, and distribute it first. So we got our 6x squared minus 8 plus 21, giving us our 13 minus our 28. Now we do the same thing we did before. Derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over denominator squared. Well, the derivative of this is 12x plus 13. The derivative of 5x is just the 5. So we now got the 12x plus 13 times 5x plus 2 minus the 5 times this entire thing. Now you're doing your distribution again and distributing your negative 5. Combine your like terms, and you get the exact same answer. So it does not matter which way you go. Just realize sometimes this distribution first is not possible, so you have to do the first option. Okay, it's your turn. Choose the method of your choice and go. Okay, let's see how you did. I did it the long way, just so you got used to it. So we take the derivative of the numerator, right here, times the denominator, minus the derivative of the denominator, which is 7, times the numerator, all over denominator squared. So now we're doing this here. We know the derivative of the first is negative 4, and the derivative of the second is 5. So we take negative 4 times your second, 5x plus 1, plus 5 times the first, 3 minus 4x, all still times 7x minus 9. Minus 9, I did my distribution here. So we had the negative 20x squared. We have, that's where I got this one from. And then I took 15x minus 4x, which gave me the 11x. Then 3 times 1 is 3, just so as in descending order. Here, we distribute this dude out. We get negative 20x minus 4, 15x minus 20x, right? So this total here is negative 40x plus 11 times 7x minus 9. Here we distributed the negative 7, so 140x squared minus 77x minus 21. Now when we did our distribution down here, we got negative 40 times 7, which is a negative 280x squared, negative 40 times a negative 9, the 360, 11 times 7x, 77x, and then 11 times negative 9, carrying down the rest. All I did now is combine my like terms. So 140 and negative 280 is negative 140x. My 77's just cancel here, giving me my positive 360. Combine these two, negative 120 over 7x minus 9 squared. Should have given you more room on that. Sorry about that. Okay, marginal average cost. Okay, we know that cost is C of x. To find average cost, all you do is divide it by x. We've actually done this before, pre-calc and here. So now when you're going through and doing this, we have to take the C bar is what denotes marginal average cost. So when you see C bar, that means average. So if this is C right here, to find the average, you divide it by 1 over x to get your C bar, or divide it by x, which is multiplying by 1 over x. Then all I did here was distribute my x through. All right, so there's my marginal average cost. Now, to find the average cost function, or to continue to find it, you find the derivative of it to give it the marginal. This x is not supposed to be here. I typed it in and forgot to delete it. So make sure he's gone. So finding that marginal average, this is average cost. This is marginal average cost. We take the derivative, so it's the derivative of the numerator divided by, or times the denominator, minus the derivative of the denominator, 2x plus 2, times the numerator, all over denominator squared. And then it's just doing your math. Do your distribution here, remembering to subtract everybody when you're done, so change everybody's sign, combine your like terms, and finished. Okay, to minimize the average cost, which is what you really want to do, I had to set the whole thing equal to 0. Well, you already know that for a fraction to equal to 0, the numerator has to equal 0, right? Because 0 divided by any number equals 0. So that means all I have to do is take the numerator and set it equal to 0 and solve this. So I took out the negative 4. Then I just did, so because you can actually divide both sides by negative 4. So this is now gone. I did the quadratic formula, and we get approximately negative 1. All right, your turn. Find the minimum average cost of 3x squared plus 120 over 2x plus 1. Okay, step 1, you have to find the average cost first, which is your C bar. Okay, I'm hoping that this recording works okay for us here. Okay, the first thing we have to find is C bar of x. To do that, we multiply this here guy by 1 over x. Remember, we're dividing by x. So it's 3x squared plus 120 over 2x squared plus x. All right, next we have to find the derivative of our average. So C bar derivative. Okay, so we take the derivative of the numerator, which is 6x, times the denominator, which is 2x squared plus x, minus the derivative of the denominator, which is 4x plus 1, times the numerator, 3x squared plus 120. So the only thing we're doing is our quotient rule, divided by the denominator squared. All right, so now we're just doing the math that goes with this. So now we're going to distribute. We're going to get 12x cubed plus 6x squared minus, let's do our distribution here. Let's do this. So we've got 12x cubed right here plus 480x plus 3x squared plus 120, all still over 2x squared plus x quantity squared. Now let's combine our numerators up here. And when we do that, we should get, okay, the 12x cubes are going to cancel. Squareds, we're going to have 6x squared minus 3x squared, which should give us 3x squared. So that is done. Minus the 480x minus 120 all over 2x squared plus x quantity squared. Right now when we're looking at this here, we need to set this equal to 0. And to do that, all we do is set the numerator equal to 0. So we're taking 3x squared minus 480x minus 120, setting it equal to 0 in order to figure out our marginal, our minimum. Okay, when we do this, we notice that they're all divisible by 3. So let's get rid of that 3 to make our quadratic formula easier. So that is x squared minus 160x minus 40. Plug that into your quadratic formula. So 160 minus the square root, 160 squared minus 4 times a times c all over 2a. And when you type that in, you should get 160 as your marginal cost. All right, I hope you did a great job. Good luck on your homework. Have a good day.